we have our acronym here, SOHCAHTOA. What's my ratio for sine? Good. And for cosine? Good. And for tangent? Very good. Alright, so we're going to just kind of refresh ourselves on finding missing sides and angles. Let's say, here on example 1, that we know this angle is 55 degrees. We know the hypotenuse has a length of 12, and that this bottom side here has a length of 9.8. We should be able to find this missing angle here. I'll call it x degrees. And we should also be able to find this missing side here. I'll call it z, to use a different variable. All right, so let's say we are looking for this angle that we labeled x. If I'm looking for x, that's the one variable that I can have in my equation. So I have to know the two sides. In relation to this angle x, the 12 and the 9.8, those are the only two pieces I know. What sides are those in relation to x?
Hypotenuse to the adjacent.
Right. And if I know hypotenuse and adjacent, then which ratio am I going to have to use? Very good. So we've got cosine of x is equal to, adjacent 9.8 over hypotenuse 12. All right, I'm trying to solve for x, so I need to get rid of cosine. What's the opposite of cosine? Inverse. Very good. And we type it in our calculator just like that. What mode do I need to make sure that I'm in? Degrees. Okay, so approximately, what's the nearest degree that we find here for x? Good. So x is 35 degrees. All right, now I'm looking for z. So z is this piece here. If I'm using the angle they gave me, which is the 55, where is z in relation to that angle? Adjacent. And I know both hypotenuse and the opposite side, so technically I have options on which one I want to use. If you want to avoid using the decimal, then you could use the 12, that's fine. If I'm using the 12 and this is the adjacent side, then which ratio am I using? Cosine again. So cosine of 55 is equal to adjacent over hypotenuse, right? And what do I do here to solve for z? Cross multiply. Right, and what is 12 times cosine of 55? Approximately 7. Yeah, 7 or 6.9. We'll just go one decimal there. We'll go with 6.9. Good job. Okay, so we've kind of reviewed how to find missing sides, missing angles. Now let's go a little bit more in depth with those angles of elevation and depression. All right, so elevation. Elevate means up, right? To go up or look up. So an angle of elevation is if you are looking up. Cosine of 55 equals z over 12. 12 times cosine of 55 is 6.9. Very good. All right, so if you look up at an object, the angle between what we call your line of sight and some horizontal line, which if you're looking up at something, you're probably standing on the ground. Is what we call the angle of elevation. Alright, so we're going to draw a picture of what this would look like. Typically, if they give you a problem where they're expecting you to determine angles of elevation and depression, they're going to give it to you in a word problem. So they're going to describe some scenario where you're either looking up at something or looking down at something. If it's an angle of elevation, you're looking up at something. So let's say you're standing over here on the ground, looking up at something in the sky. A bird, a plane, whatever you are capable of drawing. I'm not much of an artist, so I'm just going to put a bird up here. Okay? But you're looking up at something up in the sky. This is some object. Okay? My line of sight is from my eye, right, straight up to whatever the object is I'm looking at, right? So basically, from my eye, I follow this line up to the object. That is what we call the line of sight. Okay? So this is our line of sight. Your angle of elevation or depression is always going to be the angle that falls between your line of sight and a horizontal line. Well, if I'm looking up, I'm probably down here on the ground, right? So the ground is what is going to be your horizontal line. And your angle of elevation is the angle between those two lines. So this right here is my angle of elevation. Okay, so now that we know what an angle of elevation is, let's look at an actual problem where we're solving for something that's missing using an angle of elevation. So again, angle of elevation, I'm looking up at something. All right, so it says you want to build a skateboard ramp with a piece of plywood that is 14 feet long. So you're going to take a piece of plywood and angle it, like this piece of paper is plywood, and angle it so you can make a ramp. Okay? To make sure that your skateboard can smoothly transition on the ramp, so from the ground to go up onto the ramp, it has to be at an angle of elevation of 26 degrees. How high off the ground will the ramp be, and what will be its horizontal length? So how long did they say the piece of plywood was? And that's the piece that we're just laying on top, right? The part that they'll skate up. So this piece right here, 14 feet. Obviously, this is my 90-degree angle, right? And they asked us to find two pieces. They want us to find the height of this ramp. Well, the height would be this side over here. They also want us to find the horizontal length of the ramp, which would be this part here. The other piece they gave us is the angle of elevation. Well, if this is the 90-degree angle, that's one of these. Is your angle of elevation down at the bottom or up at the top? At the bottom, right? So this angle right here is the 26-degree angle. All right, we got to find both of those pieces for them. If the 26-degree angle is the piece that I'm using as my angle of reference, let's say I'm looking for x. X is the height, right? Okay. So in reference to the 26-degree angle, where is x? Opposite, right? And which piece do I know? Hypotenuse, okay? So if I know the hypotenuse and I'm looking for the opposite side, which ratio do I have to use? Sine. So I have sine of my angle, 26 degrees, is equal to opposite over hypotenuse. All right, and then how am I going to solve for x? Cross multiply, right? So I put this over 1. So really, in my calculator, I'm typing in 14 times sine of 26, right? Right. So if we're just going one decimal place, that'd just be 6.1. Good. All right. So we found the height. The other thing they asked for was the horizontal length. So that's this piece here. Where is y in respect to that 26-degree angle? Adjacent. So which ratio do we want to use here? Cosine? Okay. All right, so to find length, I have cosine of 26 degrees is equal to adjacent over hypotenuse. And what do we do to solve? What'd you say? Y over 14. So we are going to have 14 times cosine of 26, right? And what is 14 times cosine of 26? Go. So it's basically the same exact problems that you've been doing, but whenever they describe it, they're going to describe it as a word problem. You fill in the blanks. Okay? All right, so in summary about our angles of elevation, your angle of elevation starts on a horizontal line, which is going to be the ground, right? And it rises to some object that's going to be along your line of sight. Alright, so now that we know what an angle of elevation is, we said it means we're looking up at something. If you flip it over onto the back, we're now going to define an angle of depression. Well, if an angle of elevation means I'm looking up at something, what do you guys think an angle of depression is? Looking down at something, right. So that's what we're going to write over here for our definition. If you look down at an object. The angle between your line of sight, just like the last time, and that horizontal line, between that line of sight and a horizontal line, is the angle of depression. Okay, so if I'm looking down on something, that means I'm up above it, right? So if I'm looking down at something on the ground, I'm somehow raised up. So maybe I'm standing on a platform over here, okay? And I'm looking down at something on the ground. So maybe a car down here on the ground. Okay, it still is going to be your line of sight, which is where you are straight to the object that you're looking at. So the diagonal line here is our line of sight. Okay, and it has to be between that line of sight and a horizontal line. So if there's not a horizontal line, you have to draw it in. So that would be like this piece here. And the angle that's formed between those two lines is your angle of depression. All right, so the biggest difference that, the biggest problem that I see when people are trying to do angles of depression is that they're tempted to write the angle in here. Remember, your angle has to be between a diagonal line of sight and a horizontal line. This is not a horizontal line, this is a vertical line, so it can't go there. Okay. All right, so let's look at a real example. Says that you are skiing on a mountain with an altitude of 12,550 feet. If your angle of depression is 21 degrees, about how far will you have to ski to meet your parents for lunch at the bottom of the mountain? All right, so you're standing up here at the top of the mountain, about to ski down to meet your parents that are down here at the bottom of the hill. Okay, so my line of sight goes from my eyes down to the parents, right? That's who I'm looking at. So there's my line of sight. And they said we had an angle of depression of 21 degrees. An angle of depression has to be between that diagonal line of sight and a horizontal line. There is no horizontal line, so I have to draw it in myself. And the angle of depression is between those two lines. So here is the angle of depression. Okay, and how tall did they say this mountain was?
12,550 feet.
Right, so that line here should be 12,550 feet. Okay, and which piece are we looking for if we want to know how far it is from me to the parents? Right. Okay, so I'm looking for the hypotenuse. Here's my angle. So I know this side. What are we going to have to use? Sine, right? Opposite and hypotenuse. So sine of 21 equals opposite over hypotenuse. How do we solve?
12,550 divided by sine 21.
Very good. So we cross multiply and we get x times sine of 21 equals 12,550, and then we have to divide. So we end up with x being approximately what to the nearest foot? Yeah, 35,000. Is it 19 or 20 if we round to the nearest foot? 20, okay. There we go. All right, so now they want us to come up with a relationship that we notice between the angles of elevation and depression. So, elevation and depression, both of them, you've got to have a line of sight. And for both of them, you have to have a horizontal line, right? So that's up here. And down here at the ground. And then your angles are between those, right? So this angle right here would be my angle of what? Depression, right? And then this one down here would be our angle of elevation. Okay, so as far as their relationship goes, those two horizontal lines, are they ever going to intersect? So those are what kind of lines? Parallel. And my line of sight works kind of like a transversal. So what would I know about this angle and this angle? Alternate interior, which are congruent, right? So those angles should always be equal to each other. Okay? So the angles of elevation and depression are congruent, which should be our big takeaway from this page, that those are going to be the same. So for our summary, we'll just say angles of depression situation are equal angles. Between two objects.